Here we're going to take a look at decarboxylation chemistry, and then once we've learned this reaction, we'll see how it's tied into the next two reactions. So when we're talking about decarboxylation, what that means is we're losing CO2, so loss of CO2 from a molecule. And the general rule for decarboxylation is that a carboxylic acid that is beta to any carbonyl can be decarboxylated with heat. Let's look at an example. So say we have this molecule here. Okay, in relation to the ketone has a couple of alpha carbons, and then specifically at this beta carbon, we have the carboxylic acid. So if we heat this molecule up, we can actually lose the carboxylic acid as CO2 gas. I think it would be helpful though if I draw this just a little differently, and all I'm going to do is rotate around this alpha beta bond so that the OH is up near the top. Here's my OH, and I'm actually going to draw out the OH bond. And here's the carbonyl, so it's still the same molecule. And again, I'll go ahead and highlight the carboxylic acid portion. So what happens when you heat this up, you have lone pairs on this ketone in this case, and from here this reaction goes through what's known as a six-membered transition state. And what happens is the pi bond here will come up and take the hydrogen. These two electrons will push down to here to form the pi bond, and those electrons will move over here to form the pi bond. So if you track the electron flow, what you end up with is an enol plus what we've highlighted in green ends up just being CO2. So that shows where the CO2 is lost. And the enol, you already know a good bit about enols. So what this will do is tautomerize to give you the ketone. So effectively what's happened here is we've kept everything from the starting material except the carboxylic acid. Now, while this decarboxylation is specific to carboxylic acids, remember that things like esters are only one step away from carboxylic acids because they can be hydrolyzed. So that means if we take, we'll do this molecule here, where instead of a beta carboxylic acid, we have a beta ester. But if we just want this portion of the molecule, what we can do is a hydrolysis followed by a decarboxylation. So the hydrolysis would just be acid and water, and that'll hydrolyze the ester to a carboxylic acid. And then heat this up, and you'll lose the CO2. So that'll be this portion you'll lose, and then the portion that remains is this. And that's your product. Now, one thing that we'll end up doing if we have an ester and we want to do the decarboxylation, instead of doing two separate steps, it's easiest if we just start with our ester, go directly to the product by doing everything at once. So we can do acid, water, and heat it up. And that'll all happen in a single step.